The last part of this unit is looking at proofs with our similar triangles. So we're going to be using those three ways to prove that triangles are similar: angle, angle, side, 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 and side, angle, side. And we're going to be combining those with the proofs like what we did with our congruent triangles. So with our first one, they gave us a given statement, they gave us our proof statement, and they gave us our picture. So our first statement that they said is that MN is parallel to JL, and that reason is that it's given. From that, we can take some of our types of angles. So knowing that we have our parallel lines, we can say that angle M and angle J, or angle KMN and KJL, are congruent because they are corresponding angles. Looking at my picture, I also see that I have a little triangle in a bigger triangle. So that means that this angle K here is shared by both triangles. Just like we had the reflexive property with our congruent triangles for our sides, for similar triangles, we can use that similar angle using that reflexive property. So I can say that angle MKN for my small triangle and angle JKL for that big triangle are congruent using that reflexive property. From there, since I have an angle for each of my triangles, I can say that triangle JKL is similar to triangle MKN using the angle-angle similarity. So instead of using congruent, we're just using the one squiggle for our similarity. For our second proof, again, we're going to start with those given statements. So the first given statement is that angle EAB and angle DCB are right angles. For this proof, we're going to actually say what it means for them to be right angles. So if they are right angles, then that means the measure of each of those angles, so M with the angle thing means measure of, are both 90 degrees, and that's the definition of a right angle. The reason we're doing that is so we can do some substitution and say if they both equal 90 degrees, then we can say that those measures are equal to each other. So those angles are equal to each other using substitution. And because of that, since they are equal, we can say that those two angles are congruent using the definition of congruence. The next thing that we need is either some sides with our proportions or another angle. In this case, we have those intersecting lines, so I can make vertical angles. So my vertical angle would be angle ABE and angle CBD. Those are congruent with vertical angles. Again, for similar triangles, if we have two angles in each triangle that are congruent, then we can say that those two triangles are similar using angle-angle similarity. The third proof, the last proof that we're going to look at for this, is an example of a different kind of similarity. So we're going to start with those given statements. WY, it bisects angle XYZ is my first given statement. The second given statement is they told me that XY to ZY is the same ratio as YW to VY. That's my second given statement, which is right here. So that gives me some sides. And then the third thing is we can say that because WY bisects my angle, that creates two congruent angles using our definition of the angle bisector. So angle XYW is congruent to angle ZYV using that angle bisector definition. With that, my proportion that they told me in my given statement with the angles for my angle bisector allow me to say that those two triangles are congruent using side angle side similarity. So for this one, we were lucky because they already told us that they were proportional. Sometimes we might have to find that proportion ourselves. But again, just stepping it out one reason and statement at a time, using the side, 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 angle, and angle, side, angle similarity for our triangle similarity proofs.